Hi, good morning, and welcome back to our podcast. You might have already seen us before in the GeekyAnts talk show. This is a new format that we are bringing to you. So, I am Vasuki Vardhan. I work as a technical lead here at GeekyAnts, and we have Dibyaprakash over here, who is our senior software engineer at GeekyAnts. Today, we are mostly talking about gRPC and a whole bunch of things in and around that, right? And how it is affecting the modern day web and cloud. To start off very quickly, today we are discussing more about the current hype that it is going on around gRPC calls and also a few things in and around network security, right? In today's day and age, most of the API calls, all the things are happening over the internet. The most built out thing is the cloud infrastructure, right? And anything and everything that you're doing these days are going over the internet, right? And we have a lot of these protocols, right? So we have HTTP, we have TLS, we have TCP, UDP, lot of these things, right? And on a developer perspective, we are mostly used to REST, and these days we also have GraphQL coming in, right? And also from a very long time, we also have something known as RPCs, remote procedural calls,
Yes.
right? So probably let's start talking about what exactly is gRPC, how that differs from REST, GraphQL, in any of those things, right? And what is the base protocol layer and everything, right?
Yeah.
So, to give you a bit of context, right? So, at the top level, we have our two main major protocols, right? That we mostly use. Either we are using TCP or we are using UDP,
Yes.
right?
Yeah.
And as of now, most of our current day HTTP calls that we make on HTTP 1.1 and 1.2, these are mostly
TCP. Yeah.
TCP calls, right? Not usually an IODP call or
Yeah. True.
something, right? And in today's topic, we are talking about a specific uh, framework,
Yeah.
right? gRPC, which is also technically HTTP at the base layer,
Yeah.
but it is using HTTP 2
Correct.
rather than the browser dependent HTTP 1.1.
Yeah. You can call it as a layer on top of HTTP2, right? Yeah.
Yeah, it's a layer over HTTP2.
Correct.
And uh, fun fact for a lot of people who don't know, G in gRPC stands for Google,
Yeah.
right? That is also something that I recently discovered because I was till date thinking it of as a global remote procedural call because it is happening over the
Yeah.
network, right? So that was a very interesting discovery that we made when we started researching on the entire hype of gRPC.
Correct.
So to give you a bit of context, uh, gRPC RPC framework was initially built by uh, Google for their internal
Use
microservice
cases. Yeah.
communication, right? Service communication,
True.
right? Today it is widely known as gRPC. Cloud Native Foundation is now supporting it uh, fully. It is a properly incubated
Yes.
system, right? So it is gRPC as of date is considered properly cloud native,
Yeah. That is true.
right? So yeah, with that context, I can probably you can take over and talk about what is all the hype around gRPC and why it is becoming
Yeah.
more and more relatable these days.
Yeah. That is true. So basically, gRPC got trend in recent years. When microservice got the trend, right?
Hmm.
So whenever you are going for one microservice architecture for your project, So you will be like considering few like communication protocols which you will be using for your microservice communication, right? So you can use REST calls, HTTP calls, or you can use event based architectures. You can just request like manage your request and response through sockets, or you can just go for gRPC. Okay, so whenever like people started using all these protocols for microservice communication, so there were few gaps. Like in HTTP, like you will be completely strict to the like IP and the port of the other service for in order to establish that communication. But in gRPC, it's a like a two-way contract. So you are like handshaking with each services. Like one service will be like handshaking with another one, and the communication will be happening very seamlessly, and it is strictly typed, you can say. So there is something called like protofile. So Google calls it as protocol like protobuffers. So you will like it's just like schemas. So first you will have to create your protobufs, and you will have to share that in each microservices so that they can talk and in a like strict manner. So that is considered by most of the people like gRPC is the best option to perform microservice communications. But it all depends on your use case. If you want to perform one synchronous request, then you need not to go for gRPC, right? So you can just directly go for REST. Yeah.
GraphQL and all those things.
Yes.
So in terms of protocol buffer, right? This is mostly a custom binary that is being run.
Correct.
Right. So you have this, as you mentioned, you have your dot proto file.
Yeah.
Which is basically like your Kafka. So it is mostly like what I'm getting from that is I see a lot of at least in the contract specification, I see a lot of similarities between what we used to have with SOAP and what we have today with GraphQL.
Yeah, that's true.
Right. So in the back days, we had SOAP APIs where we had WSDLs.
Yes.
That was being shared across.
Correct.
Which became the new normal of how you configure clients.
Yes.
Then we had REST, which was more or less ambiguous.
Yeah.
I mean, we have OpenAPI spec for that matter, but
correct,
that itself is not what binds you, right?
Yeah.
And today we have GraphQL.
Correct.
Which also requires a schema.
Correct.
Right? Schema.GraphQL.
Yeah.
But as you particularly mentioned, I'm very curious on this point. Right? See, with GraphQL, right? Even though I have a schema.GraphQL file, it is not necessary for my client to be also in interpreting those schema files, right? I can also call my GraphQL endpoint as a post call.
That is true.
So there is still a possibility where you really don't want to have a two-way handshake for some reason.
Correct.
Right? So let's say you're calling your entire application is calling REST APIs, and there is this one particular out of the blue microservice which came in, which is using GraphQL.
Yeah.
Right. You really don't want to bloat up your application with an GraphQL client like Apollo or something.
Yeah,
right?
That is true.
So people tend to use post API. So you actually don't need a two-way handshake, right? But what you're telling with gRPC is you actually need a two-way handshake.
Yeah.
With the protocol buffer.
Correct.
Right. So this eventually changes a lot of things for us.
Yes.
Right. So now what we are telling is, if you want to use gRPC, then you will have to follow these particular pointers.
Correct.
Right. Yeah. It's more or less like a framework. RPC framework. To name itself as it. You have a specific way to do it.
Correct. Yeah.
Right. So okay. So let's say that I also read about you having it to be called as a local object. Right. Yeah. gRPC allows us to do that.
Yeah.
Right. So eventually it is something like you have a function written.
Yeah.
And let's take a simple Node.js example or a Java example, right? So you export one particular function out of a file or a library, and then you import it somewhere, and then you are using it,
Yes.
natively using it, right? So now it is properly a object oriented invocation that you are having, right?
Yeah.
You particularly invoking that particular functional implementation, or you're invoking that local object, whatever it is. And gRPC is mostly like that.
Yeah. So it aims to provide you that similar functionality over the network. So it
Or the network.
Yeah.
So that is one point.
Correct.
So assuming that, if I'm not wrong, that is where your protocol buffer comes into play.
That's
play,
true.
right?
Yes.
So you're actually invoking a local object over a network.
Correct.
So that is why all this, not wrong, why we need this protocol buffer handshake that is happening before.
Yes. It's just like both the sides should know the definition of what being passed over the network, right? So like in that way only it will be seamless. Like you will feel like you are calling one local function only instead of calling one network function. So yeah, that is the aim.
That is the aim, right? So again, with a lot of things, right? Let's take these days microservices itself. So now we have a bit of context on what exactly gRPC does.
Yes.
Right. So let's take a bit of microservices that we are having these days. Let's say we have a product X which has around 20 odd microservices running at the backend.
Okay.
Supported by a front end. Right. As of today, at least from my knowledge, there is no particular by built-in things in browser to call a gRPC thing, right? So if I'm not wrong, it is still REST.
Yeah.
Your application is call will be still be REST.
Yeah, that will be HTTP, like through HTTP protocol only.
Right.
Yeah.
So now let's come to the backend, where I have 20 odd microservices. Each and every microservice is talking to each other in some or the other way.
Okay.
Right. So now this is where I see a larger potential to have gRPC.
Yes.
Right, where we have service to service invocation.
Correct.
Right. So now, if as of today we are using REST, and so T1 times GraphQL.
Yeah.
Right. So where and when and how you want to use gRPC over here?
Yeah.
Well, let's say we already have a set of APIs which are already in REST. Let's say these microservices are already talking to each other via REST, which is mostly the case scenario.
Yeah.
Right. So now let's say we want to bring in gRPC. Right. So how would it benefit it using over REST, and why gRPC over REST?
Okay. Yeah. So to answer this question, first of all, we need to discuss our use cases. Okay. So like we will be talking about like REST using HTTP and GraphQL and gRPC. Okay. So let's talk about GraphQL first. So GraphQL is something when you have one client, like if your front end is in like React.js or something, and if you have any backend in Node.js or Spring Boot, then you can just directly go for GraphQL, right? So there will be no need of implementing gRPC, because that can be done like in a better way in GraphQL. Like if you are requesting a specific set of data from server, then you can just go for GraphQL. That will be really seamless for you. In other hand, like if you want to perform some synchronous API calls, then you can just go for HTTP. Again, for front end and back end communication, I'm saying. Okay. But when it comes to back end and back end communication, if you have two service A and service B, and that time you want to perform some API calls in between those two services. Okay, if you need any kind of data like user details or like booking details, something like that, so you can opt out for either gRPC, or you can say REST, normal HTTP. Okay, GraphQL is not a really suitable way for microservice communication, isn't it? Like there is no requirement of such like schema definition stuff for microservice communication, you can say. Okay, so we left out with two things. One is REST using HTTP, and gRPC with HTTP2. Okay, so there will be more specific scenarios. Like if you want like very particular set of data, and you don't want to compromise with the latency, like waiting time. Okay, so if you want to perform that operation faster, then you can just go for gRPC. You will have to, like, if you have a limited set of data, you can just easily write your protobuf, right? So then you just share the protobuf to each services, then you can just get the data using API calls, gRPC API calls, right? So I'll just give you an example. Like if you want to perform some authentication in a service called booking service, okay, so you need that user data before performing anything. So you are calling user service. That time you can just call user service for getting the like user details. Okay, that will be the ideal use case for gRPC basically. Yeah, so that is it. And like adding to this, there is one more point. Like gRPC provides you inbuilt authentication as well. Okay, so it provides a lot of features. Like if you'll see, gRPC provides you inbuilt authentication, plus it will provide you automatic retry mechanism options as well. Okay, so if you are calling one API of service 2 from service 1, if it's normal REST and HTTP, if it fails, then you will just catch the exception. Okay, you will check the error, and then you can perform retry, right? Like normal REST HTTP will not take care the retry mechanism. Correct. But in gRPC you can actually configure. It will be like retrying according to the error, and it will be like there is a certain time up to when it will retry, and it will finally let you know like, yeah, this is failed due to this. But it will take care like 90% of those error scenarios. That is a really good thing. And like authentication layer, gRPC provides by itself only, so you can configure and you can use that as well. Yeah,
so basically just like your TLS handshake that you are having.
Yeah, true.
So you already have a signature that you pass through.
Correct.
With TLS you already have the securities in place, right? So in that case scenario, that means even with gRPC we are still having the issues of having to either overfetch or underfetch data that we have with
that is
REST. True. Right, so that is not yet solved. So good. On that front, we have a bit of idea on where and how to use gRPC, right? And from that we switch over to something which is more generic, right?
Yeah.
So we're mostly doing this for network security. gRPC does a lot of things really good. It is performant. It also handles low latency.
Yeah.
And just as like your normal, probably like your WebSocket, it uses a unary stream, so it is a bidirectional
correct
traffic, right?
Yeah, that is another interesting point you can mention. Like if you are using RESTful with HTTP in your service, and if you have one requirement to expose one socket to your client, in that case what you will do, you will have to add socket layer as well. Like you have to rely on another protocol for performing socket operations. But if you are using gRPC, it provides you both synchronous and like you can just perform bidirectional streams as well, bidirectional calls. So there is no need of another socket layer for performing those like pops up activities. So you can do that in gRPC.
So it is basically you are having to hold a single connection, right?
Yes.
It's a unary
correct
stream. So either you want to do it for synchronous activities, you want to do for asynchronous activities, it is just one single connection that you are maintaining using the protocol
Correct.
buffer.
Yeah, actually, like if you will go more internal to that, it uses one feature of HTTP2 that is called as multiplexing. So that means while you are in a single connection, you can actually perform multiple requests. Okay, so by using that feature only, gRPC is capable for doing this seamless bidirectional communication. Yeah, but which is not present in HTTP1.
So basically, we have a lot of these advantages
Yes.
that we can usually have. Rather than making multiple network calls,
Mhm.
you have one active network call, you make simultaneous requests on the same channel, you're receiving responses on the same channel, so you don't need to worry about it.
Yes.
And also in terms of security, I think it is a lot more better, right? Because you're using a buffer.
Yes.
That means the data that is actually being transacted is by default not human readable.
Correct.
Right? It's a byte array that you're sending over,
Yes.
which is only understood by machines.
Yes.
And you put TLS over that, so it is mostly non-readable, right? It is
Yes.
mostly what I can say is it is a lot more resilient towards man-in-the-middle attacks.
Yeah, that is true. Like both of your services are having those proto files, right? Only services knows what is the definition of your request and response, and that is true. So if someone breaches in the middle, if someone tries to read their data, so they cannot read that because they don't have that protobuf with them, right? So it's inside our microservices. We are not exposing those proto files, so that is way more secure.
So yeah, it is more or less like your private key, public key.
Correct.
Authentication.
Yeah.
You only your server and client knows what is being
Sent.
transacted, right? So cool. So as you said, it is performant. It is it due to the streams we have low latency on things, and it is also more secure.
Correct.
Right? All things related to RPC, and it also borrows the network level security from HTTP2 and TLS 1.3.
Yes.
Right. So with network security in mind, so if we switch over and deviate to our next thing for the day, right? Network security in general.
Yes.
Right. So we got a good idea. Okay, we can use gRPC to make our internal communication a lot more secure.
Yes.
Or I can also make sure that if I am calling any other backend services like my microservice calling some Google service, I can still make use of gRPC over there.
That is true.
Right. So our backend communication is a lot more secure with gRPC.
Yes.
Right. So now coming to our regular day-to-day web, right, where we actually don't have gRPC being widely used anywhere, or neither is the entire ecosystem anywhere close to using gRPC on a day-to-day basis.
Yeah, that's true.
Right. Even today we are doing on HTTP over REST.
Yes.
And sometimes over GraphQL. Right. So coming over there, we have a lot of these things, right, that you'll need to make sure of. You have things on DDoS attacks.
Yes.
You still have man-in-the-middle attacks. You have SQL injection. A lot of these breaches, right? So looking into it, what are all the things that you would suggest going into, or for, let's say, a project is starting over, right, and they decide to go with gRPC at the back end. So now they're looking into the entire web stack where they can actually integrate their front end with their back end.
Okay.
Right, and obvious way right now is REST or GraphQL.
Okay.
Right. So what are all the things that they could do in terms of making sure that they are secure over the network?
Okay. Yeah. So like to answer this question, first we will have to figure out what are the 2 or 3 options in terms of project kind. Okay. So whenever you develop one project, either it will be like one open world internet exposed like project, and otherwise you can just deploy that in your private network. So there are two use cases, right? So like private network in the sense like if you are developing some project for your own organization, and everyone who is like using your VPN can be like can access that particular website or something project. Okay, but in terms of internet exposed like projects, there are more risk in terms of security breach. Okay, security breach you can say, or DDoS attacks. Okay, so let's talk about DDoS first. By considering like you are developing one internet exposed project. Okay, so DDoS attack is something like they whoever does that, like whoever performs that DDoS attacks, they don't need any of your data. Okay, so their intention is like to make your service down, like service unavailable completely. So what they will do is like they will be keep on hitting like lakhs of like request to your server, and you obviously your server was is not capable enough for like handling that. If you have vertical scaling or horizontal scaling, it will scale, but until a limit, and it will
Fail
increase.
post that.
Yeah, in it will increase your resource utilization as well, right? So like that is the aim of DDoS attackers. Actually, they don't need of any of your sensitive information. They just want to like
Bring service down.
bring service down. So like in order to handle that, you have to define a rate limiting basically. Okay, so if you are getting many requests from single origin, okay, that is suspicious. So you have to restrict that. So if you are using any cloud providers such as Cloudflare, they provides you option to configure your rate limits. Okay, so in order to prevent DDoS attacks. But if you are using your own components like in your hardware infrastructure or like virtual infrastructure, so there you can configure the rate limiting in Nginx. Okay, so that is server level. I am saying server infrastructure level. But if you are planning to handle this rate limiting inside your microservice architecture, then you can just configure those things in API gateway. Okay, so you have used Spring Boot microservice architecture, right? So Netflix actually Joule provides API gateway. So they actually provides option to configure rate limiting. Okay, so what will happen is only API gateway will be affected by that DDoS attack, right? Still API gateway will be having getting those requests, but it will not allow other services to be affecting with those requests. Yeah, so that is something to answer your question, how to handle DDoS attacks. Okay, and next is man in the middle. So for that, obviously we can go for TLS, as I said, 1.3 is more secure, so you can implement that. And private key, public key, you can say implementation also you can do. Yeah.
So on that front, so we have your APIMs, and these days a lot of these cloud providers also provide these gateways, right?
Yeah.
So we have Azure's APIM, we have AWS provides
Yes.
API gateway, then we have Apigene and Google. Lot of these people take care of
Correct.
your DDoS and regular day-to-day attacks, right? So
Yes.
even in terms of SQL injection, a lot of these things are by default handled by those. Or also as you said, we can also do it using an Nginx load balancer or even a Metal LB.
Yes.
At the load balancer level also it can be done. Or else if you want to do it at the code level, we have in Java we have something like Joule, or even use some circuit breakers like Hystrix.
Yes.
Right. So that is something that is properly doable. So now coming to an internet exposed gRPC. Right, coming back to that. So now we have a bit of idea on a few things on the security level. So I guess since we are using protocol buffers and a lot of these tight contractual points, right? So your DDoS is also something that becomes a lot more harder.
Yeah.
Right, because you'll need to somehow catch hold of the contract, the protocol file, the dot proto file, the authentication, all those key sharing
Correct.
things, right? So in some terms, you are already a bit more secure towards DDoS attacks
Yes.
and also man in middle.
Yeah.
Right, because the person who is trying to intercept is actually intercepting a byte array
Mm-hmm.
over the actual data that is being transferred.
Yes.
Right. So we also have things like HMAC, RSA, all these things, right? So where and when, if this is even remotely relevant to
Yeah.
what we're discussing these days, how does it work out?
Yeah. So basically, like if you are sharing any sensitive information to your client, such as front end, so obviously those information is completely visible to normal user. Okay. So like in that case, what will be happening? Like those are like human readable, obviously, and that is like you are not, like, let's say you are not encrypting that. Okay. But if the sensitive information is present in your response headers or response body, then you can just like perform HMAC 256 like encryption. Okay, you will just have that key with you. Okay, and if you are sharing that to front end and front end is sharing back that hashed value to you, so then you can just decrypt that using your key. Okay, so in that case what will happen is like there is no need of you can say exposing that particular data in human readable format, and that is way more secure, I can say.
So this is something that we can do with HTTP REST
Yes.
calls as well.
Yes.
Right.
Yeah.
So we provide a public key to the front end. Front end houses a public key, which is then used by our server for decryptions.
Yes.
Right. So something like how we do it with SSH.
Correct.
Things. Right. So cool. I mean, that was a really good, insightful thing into gRPC and network security. Right. So to sum it all up, it is basically gRPC, as we discussed earlier, is a lot more performant, low latent, and inherently a lot more secure. You can use gRPC in backend one-to-one communication, right? And it is mostly supported by all of of your native languages.
That's
right.
True.
So, and since it is a tight contractual framework, a lot of things like man in middle, DDoS, a lot of things are handled by default on those system, and it uses a unary duplex stream, so you can do a lot of the synchronous and asynchronous calls using one single connection. Right. And since it is using HTTP2, it is by default a lot more secure and better than your regular REST calls. Right. On the cons side, we still have the same issue as of REST. We still would have the issue of overfetching and underfetching things, which GraphQL really solves it. And also we don't really have really great browser support as of today, so that we can have gRPC
for client communication
everywhere.
Like front end communication, you can say.
Right. So so this is all about gRPC. Right. So that's it from us today. Thank you for Dibyaprakash being here.
Thank you.
And also really thankful for all of you guys being here. We'll be back very soon with a new topic.